See this? The Hussey diagram of a lattice containing x, a, b, c, d, e, y. So how many elements in total? I think 7 elements. Okay, is given below, which means this is the Hussey diagram which is given. Then they are asking which of the following subsets of L or sublattices of L. Now they are not asking about whether the subset is a lattice or not, like the earlier example. Here they are asking whether the subsets are sublattices or not. Okay, now just see this, how to answer this one. So whenever they give you this diagram, this lattice diagram, and then a subset, try to draw the subset lattice diagram the same way it is present in the original diagram, right? And if there is a path between two elements, try to replace it with an edge. So see this, I'll just tell you how to draw it. Now the first one is x, a, b, y. So x is here, a, b is here, and y is here. See this? So x is here. Now in the original diagram, a, b are directly related. Therefore x is related to a and x is related to b. Therefore I am directly writing it. But then if you see the relation between y and ab, a is related to y transitively, but then a is definitely related, and similarly b is related to y transitively, but it is definitely related. That is why I am just putting y here, and I am putting a edge here and a edge here. And even though x is related to y, I am not trying to put the edge between a and y, sorry, x and y. The reason is they are somehow indicated, the relation is somehow implicit there through a and through b. So through a and through b we know that already x is related to y. Got it? So with practice you will understand how to write it. So simple, I am just writing all the points. If they are directly related, I am putting the edges here. If they are transitively related also, I am putting the edges here. But I am just not putting the transitive relations if they are somehow implicit. For example, I could have put the edge between x and y, but then I am not doing it because it is implied there, right? But if I don't put an edge between a and y, it will not be implied by any other means. That is why I am putting an edge. Okay. Now see this. Okay, so is it a lattice or not? When can you say that a subset is a sublattice? First thing is it has to be a lattice, which means for any two elements there should be least upper bound and greatest lower bound. But if you see this, for any two elements it is definitely having least upper bound and greatest lower bound. Therefore it is a lattice. Now when will it be a sublattice? So first thing is you should see that it is a lattice. After seeing that it is a lattice, you should check whether it is sublattice or not. There comes the main part. Now try to find out the greatest lower bound and least upper bound for every two elements, for a pair of every two elements, and the greatest lower bound and least upper bound should be same, right? So which means let's see this. If you look at a and b, here the least upper bound is y and greatest lower bound is x. If you look at a and b here the least upper bound is c, so they are different. That is why it cannot be a sublattice. If it has to be sublattice, for every pair the greatest lower bound and the least upper bound should be same. So now if you see this, if you see the least upper bound of a comma b in this diagram, in this subset, it is going to be y, right? But in this given original diagram, the original lattice, the least upper bound of a comma b is c. So both are not equal, and so it cannot be a sublattice. Got it? So even if you find one counter example, it is enough to say that it is not a sublattice. Got it? So it is a lattice but not a sublattice. That is the difference. It is a lattice because for every pair of elements there is greatest lower bound and least upper bound, but it is not a sublattice because the greatest lower bound and least upper bound are not same as the original lattice. Got it? Okay, now let's see the next example. X, a, c, y. So x is here, a is here, c is here, y is here. All are directly related, right? So if you try to put it, x is here, a is here, c is here, and y is here, right? So now whether it is lattice or not, clearly it is a lattice because you can take any two elements and you will see that there is definitely least upper bound and greatest lower bound. It will fail to be a lattice only when you have more than one maximal element or more than one minimal element, but here you have only one minimal element and one maximal element. Therefore every two elements are definitely going to have greatest lower bound and least upper bound, right? Now other thing you should verify is for every pair the greatest lower bound and least upper bound should be same. So see this, for x and a, the least upper bound is x, greatest lower bound is a. Yes, true. For a and c, least upper bound is a, greatest lower bound is c. Same is there here also. And for c and y, least upper bound is c, greatest lower bound is y. Least upper bound is c, greatest lower bound is y. Why? Because if you have two directly related elements like this, if a comma b are related, then we can say that the least upper bound and this is the greatest lower bound, that we already know. So in fact you can take any two elements and we can see that the the GLB, greatest lower bound, and LUB are same in both the diagrams, right? So in the original as well as this one, they are same. So we can say that it is a sublattice. It is already a lattice, now it is a sublattice. The reason is they are having the same GLB and LUB. So it is definitely a sublattice. What about the next one? X, A, E, Y. So X is here, A is here, E is there, right? So X is related to E, isn't it? X is related to E through B, but since B is not there, I am directly trying to put the edge there to show that it is related. And Y, A is related to Y and E is related to Y, right? So clearly it is a lattice because for every two elements there is greatest lower bound and least upper bound. But then is it a sublattice or not? So see this, for A and E, if you check A and E, what about the greatest lower bound? So for A and E, here the greatest lower bound is X, here also X. For A and E, the least upper bound here is Y, here also Y. Therefore for A and E it is satisfied. And similarly you can check for E and Y. So E and Y are directly related here and directly related here, therefore they will obviously be satisfied. X and E, for X and E you can see that the greatest lower bound and least upper bound are X and E respectively, same here, and for X and A also same here, and for A and Y also same here. So we can see that for every pair of elements, the least upper bound and the greatest lower bound, they agree for in both the diagrams. So what can we say? It is a sublattice. It is definitely a sublattice. Now see the next one, X, D, E, Y. So you are going to have X here and D, E. So X is related to D through A and then E through B, transitive relation, that is why I am putting an arrow, and then Y here. D is related to Y and E is related to Y, right? Now if you see this, D and E, the least upper bound is Y here and the greatest lower bound is X. So D and E, the least upper bound is Y and the greatest lower bound is X, right? Yes, so it is same, and for D and Y it is same, Y and D it is same, and D and X it is same, and E and X it is same. So it is same in all both the diagrams. It is definitely a sublattice. You can take every pair and you have to check it. Yes, if you check it you will get it. And next one is X, C, D, Y. So X is here, X, C. X is related to C, and then D. X is related to D, and then Y, right? So now if you see this, if you see D and C, the least upper bound, the lowest upper bound or the least upper bound is Y and the greatest lower bound is X, right, for D and C. But there, see this, let me say the greatest lower bound of D and C in the sublattice is X, right, but the greatest lower bound in the given lattice of D and C is A. Therefore these two are not equal. Even though it is a lattice, it is not a sublattice. It is definitely not a sublattice. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities, but whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is, we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.